Which of the following is correct order of bond strength? First of all, bond order is directly proportional to bond strength. As the bond order increases, bond strength increases. So we'll calculate the bond order by using molecular orbital theory. First one, N2, if we consider the number of electrons in N2 molecule, 14 electrons. Molecular orbital electronic configuration for N2 molecule is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2p x2, pi 2p y2, sigma 2p z2. This is the molecular orbital electronic configuration of N2. Bond order is equal to number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbitals by 2. Bonding molecular orbitals are orbitals without star. Anti-bonding molecular orbitals are orbitals with star. So number of electrons in bonding molecular orbitals, here it is 10. Anti-bonding orbitals contains 4 electrons by 2. So 6 by 2. So the bond order is 3 for N2 molecule. Then similarly for N2 plus, if we calculate the bond order, here number of electrons in N2 plus 13 electrons. 1 electron is less than N2. That means we can remove the 1 electron from sigma 2p z orbital. So the bond order, if we calculate, number of bonding molecular orbital electrons are changing. For N2 it is 10. For N2 plus 1 electron is removed from sigma 2pz, which is bonding molecular orbital. So number of electrons in bonding molecular orbitals 9 minus number of electrons in anti-bonding molecular orbitals is same, 4 by 2. So 5 by 2. So the bond order is 2.5 for N2 plus. And then N2 minus, if we calculate the bond order, first of all here N2 minus, total number of electrons 15 electrons. 1 electron is more than nitrogen molecule. 14 electrons, if we consider in case of nitrogen molecule, 14 electrons are filled up to sigma 2pz. Now the 15th electron will enter into pi star 2px orbital, which is anti-bonding molecular orbital. So the bond order, if we calculate for this, number of electrons in bonding molecular orbitals 10 minus number of electrons in anti-bonding molecular orbitals, in N2 it is 4, in N2 minus 1 electron is entered into the anti-bonding molecular orbital only. So total number of electrons in anti-bonding molecular orbitals 5 by 2. So the bond order in this case N2 minus is 2.5. Now as I told earlier, as the bond order increases, bond strength also increases. So here in these three, N2 is having more bond order than N2 plus and N2 minus. So bond strength of N2 is more than N2 plus and N2 minus. But N2 plus and N2 minus bond orders are same. But here N2 minus is having less bond strength when compared with N2 plus due to the presence of the one unpaired electron in anti-bonding pi orbital. That is in case of pi star 2px orbital particularly. So due to the presence of this electron, unpaired electron in case of the N2 minus in pi star 2px orbital, N2 minus is having less bond strength than the N2 plus. So the bond strength order is N2 greater than N2 plus greater than N2 minus. That is a bond strength order for this.